Then take the first vertex from the object and using the first vertex indexed by the face, then take the second and the third vertices used by that face. Then calculate a vector 1, which is the vertex 2 minus the vertex 1, and another vector 2, which is the vertex 3 minus the vertex 1. Then calculate the area using the length of the cross product of vector 1 and vector 2. And just for testing, calculate another area using the mashup method, get face area from the object's first face. Now, if we would evaluate the script, we see that the area 1 is twice as large as the area 2, so we can divide by 2, because this is the area of the parallelogram and this is the area of the face. Now, evaluating the same code is going to deliver exactly the same result from both calculations. This is our manual calculation, and this is the calculation that MaxScript performed using the getFaceArea function. The direction of the cross product vector depends on the order of the points defining the vectors. It is always pointing in the direction that sees the points in counterclockwise order. If we would reverse the order, for example going in the opposite direction, in clockwise direction, then the vector would point in exactly the opposite direction. Right now the z coordinate of our resulting vector is positive, then the vector would become negative. We can test this by using parts of the same script. This time we're going to calculate the cross of the vector 1 and the vector 2, and then calculate two new vectors, 3 and 4, and this time we'll inverse the order of the vertices. So the second vector is pointing exactly the opposite direction compared to the previous test, and then we'll calculate the cross product of 3 and 4. Now, if we evaluate this code, we're going to see that the result of the cross product in the first case has a positive z-axis, and in the second test it has a negative, but exactly the same length, just pointing in the opposite direction. Using this fact, we can easily determine when the order of the vertices changes, or the positions of the points defining the vectors that we are using.